Hello students, this is Miss Dalton. Welcome back from your Christmas break. This video is over function operations. In this video, we're going to look at some function operations. So we're going to look at it in function notation. You've done all the operations before, but it's just seeing it in different notation that might be somewhat new to you. We're going to start with just adding and subtracting functions. When you add or subtract, you just combine like terms and then simplify. Make sure you're careful of the signs when you're subtracting because you will need to distribute that subtraction sign into the second polynomial. So in this first example, we have f of x being 3x and we have g of x being x minus 5. Again, remember that f of x is just a name. It's like y, and g of x is just a name as well. And so we're not really doing anything with those. That's just naming that function. The f function is 3x. The g function is x minus 5. Now, in what we're going to do on this is we're going to take f of x and we're going to add g of x to it. When you do that, you're just taking that f function, 3x, and you're going to add to it the g function, which is x minus 5. And then you're going to just look for similar terms or like terms. So 3x plus x is 4x, and then you have minus 5. That's simplified, so that's your answer. Now look at f of x minus g of x. So we're going to take our f of x, which is 3x. Every time you subtract, I want you to do subtract, and then I want you to put that next function in parentheses. So the next function is x minus 5. We do this because we have to remember that we're going to distribute that negative into that function before we start combining like terms. So when I do that, I just change this to a plus sign. I put the negative here, and I change this. So what you're doing is you're changing the sign of everything after it. Then you combine your like terms. So we have 3x plus a negative x. That gives us 2x. And then the plus 5 doesn't have anything like it, so it just gets added on. Multiplying functions. Remember, when you're multiplying functions, you either need to use the distributive property or FOIL. When you're multiplying, you'll use FOIL if you have more than one term. You combine your like terms and simplify. Again, still be careful of the signs. And then multiply and simplify again if you're needed to when you're multiplying 3 or more functions. In this first example, we just are going to take f of x, the same f of x and g of x that we used in the previous one, but we're going to take f of x and we're going to multiply it times g of x. So if I take f of x, which is 3x, and I multiply it times the g of x, which is x minus 5, this is a monomial times a binomial, so monomial we're just going to distribute. 3x times x, remember that's 3x squared. And then 3x times a negative 5 would be minus 15x. And then that's all you have to do because we're just simplifying, and that's it. Okay, dividing functions. When we're dividing functions, for right now, we're just looking for things that can cancel. So we're going to factor each function completely if we can, and then we'll cancel out common factors in the numerator and the denominator. So we're going to do f of x divided by g of x. You can see that your f of x is right here. F of x is 2x squared minus 5x minus 3. We're going to divide it by g of x, which is x minus 3. Okay, now x minus 3 is a linear polynomial, so you don't have to factor that one. But the top polynomial in the numerator is quadratic, so we will have to factor that. Okay, now I'm not going to go through the factoring again. It's not going away. Those of you that were hoping that you wouldn't have to factor again, it's not going away, so you're going to have to go back and look at your factoring rules if you've forgotten how to do it. I know that this goes ahead and factors 2x plus 1 times times x minus 3. Okay? Now, again, if you need to go back and factor that on your own, do that. You can either use the box method or grouping, but that is what you should get, and so hopefully you recognize that I can cancel off the x minus 3, and so therefore f of x divided by g of x is equal to 2x plus 1. Okay, some more complicated examples. We have our functions up at the top, so f of x equals 2x plus 5, g of x equals x plus 3, and h of x equals negative 3x squared minus 8x plus 3. In this first example, we're going to do 2 times f of x, and then we're going to add to it 3 times g of x. So go ahead and substitute in your functions. So we have 2 times 2x plus 5 plus 3 times x plus 3. And now you're going to just distribute and simplify. So distribute the 2, you get 4x plus 10, plus distribute your 3, 3x plus 9. Combine like terms, 4x and 3x is 7x, 10 and 9 is 19. And that's simplified, so that's your answer. Look at the next one. So we have 3 times g of x, which is x plus 3, subtract f of x. Now I'm going to put this in parentheses because we're going to have to distribute that subtraction, 2x plus 5. So go ahead and simplify in the parentheses first. Let's go ahead and change the subtraction. So change that to plus. This would be negative. This would be negative. And now let's combine like terms. So we're going to have 3 parentheses x plus a negative 2x is negative x, and then 3 plus a negative 5 would be a minus 2. Then now just distribute the 3, so you get negative 3x minus 6. All right, last one. I'm going to get a new slide to do this last one because I think it's going to take more room. Okay, so on this next one we have f of x, which is 2x plus 5. We're going to multiply it times g of x, which is x plus 3. And then they just want us to subtract the x plus 1. So we're going to go ahead and do the multiplication first. So go ahead and use FOIL for that first one. So 2x times x is 2x squared. 2x times 3, 6x. 2x times x, oh, I'm sorry. Sorry, not 2x times x. 5 times x is 5x. And then 5 times 3 is 15. We're going to subtract the next part, so go ahead and change that. So plus, negative, negative. And so this would be minus x and then minus 1. Now go ahead and look for your like terms. 2x squared is the only squared term. So we'll have 2x squared. Then we're going to have 6x plus 5x plus a negative x. 6 and 5 is 11 minus 1, that would be 10, so 10x. And then we have 15 minus 1, so that's going to be 14. And that is your answer. That's the most simplified you can get. Okay, one more example. We've got the same functions that we had on the previous slide, 2x plus 5 for f of x, g of x is x plus 3, h of x, so on. We've already done this one, so we don't need to do this one again. But now we're going to do h of x divided by g of x, and then we're going to square it. So h of x is the negative 3x squared minus 8x plus 3, and we're going to divide it by g of x, which is x plus 3. So, and then we're going to square it. Okay, well, we need to go ahead and factor that numerator. Now, it is going to factor as negative 3x. Let's see. This will be x plus 3. And this should be a plus 1 right there. Again, use your factoring tools to be able to factor it, but that should work. And then we're going to divide it by x plus 3. We're going to do all of that, simplify that, then we'll square it. Okay, well, the x plus 3's cancel. Then when we have the negative 3x plus 1 that's going to be squared now, I'm going to write that over here. So now you're going to have negative 3x plus 1 squared. Well, remember, you need to write that down twice. Squared means we write it down twice. Don't distribute it, because that's not correct. We want to write it down twice, and then we use FOIL. So negative 3x times a negative 3x is 9x squared. Negative 3x times 1, negative 3x. Negative 3x times 1, negative 3x. 1 times 1 is 1. So this will be 9x squared. Combine these, so that'll be a minus 6x plus 1. That's your final answer. Okay, so again, just function operations is using your addition, subtraction, multiplication, and division tools and just getting it down to simplified form. All right, if you have any questions, you can message me or you can ask in class.